Welcome everyone into the third day of this edition of EVConIndia. I, on behalf of Blue Circle, would like to take a few moments to thank all our esteemed partners for putting their shoulders to the event. A special thanks to our main sponsors, Log9 Materials and Hero Electric, knowledge partner Alvarez and Marcel for creating the white paper, investment partner Indian Angel Network for co-authoring the Startup Ref program, accelerator partner Huddle, and real estate partner JLL. It's been an absolute pleasure working with their teams and getting their valuable support. Also, a big shout out to all my team members for working all the hours to pull this off. Thank you also to our distinguished audience for joining us, most of whom are CEOs, CXOs, and senior leaders. Many of them are our members and are repeat visitors to our webinars. This is very encouraging and motivates us to provide even higher levels of dialogue. For those of you who are new with us today, India-based startup Blue Circle is the world's first sector-specific opportunity and knowledge exchange networking app for business leaders. It is somewhat like the sector-specific LinkedIn for senior leaders, a space to have meaningful conversations, connect with over 15,000 plus rapidly growing community of like-minded leaders from India and across the globe, exchange high-quality curated content, and access business opportunities across 20 sectors, such as e-mobility, renewable energy, real estate, chemicals, and many more. Those leaders among you who are interested, please do join us. Coming to today's discussion, it is a privilege and a pleasure to welcome Mr. Vikram Handa, founder and MD Epsilon Advanced Materials, our distinguished keynote speaker who is handpicked because of the thick input and the rich experience he brings in. Under his leadership, Epsilon is poised to become the preferred supplier of synthetic graphite anode material used in lithium-ion batteries for electric vehicles and energy storage applications across the globe. Apart from the anode material manufacturing facility, Epsilon has also set up a target-oriented R&D laboratory at Vijayanagar to cover a complete array of cell testing facility, including carbon material testing, coin and pouch cell testing to improve the quality of the material by continuous development. Mr. Handa, I'm also happy to share that Mr. Handa has recently been nominated as chairman for World Economic Forum Task Force on Battery Supply Chain. Now coming to the discussion, which will revolve around the topic, which is India's opportunity in the global battery material supply chain race. Now I request Mr. Handa to please begin the session. Thank you, sir.
Thank you, Gautam, and good morning to everyone. Just a second, I'll just share. So I think everybody is very well aware about the potential EV growth that's going to happen in the next 7 to 8 years. There are lots of statistics out there that talk about 2.5 to 3 terawatt hours of demand coming in by 2030. And recent news by Tesla even talks about it going past 5 terawatt with their captive demand adding to this. There's been a lot of talk about cell prices coming down. So, everybody thought at $100 a kilowatt hour, it will be the inflection point where EV adoption will happen very fast. But due to the commodity cycle, actually battery pack prices have been going up in this year. But Goldman Sachs expects it to level down in the next 3 or 4 years as commodity prices cool down. And recently in the last 1 year, not only in India, but LFP seems to be the driver of preferred cathode in cells. This is mainly due to, say, innovation and more development on the LFP side, and LFP getting closer to giving NMC kind of performance. Right. So today on our topic, we're going to touch this part, which is stage 2 and 3. Of chemical processing and anode and cathode production in India and the opportunities that lie within the Indian ecosystem. So the government has been addressing the downstream demands of application with the FAME 1 and 2 policy and the auto component PLI. And with the cell manufacturing, they focused on the ACC scheme, which was oversubscribed. And we see a lot of traction with the customers who won the PLI scheme and the people who didn't win, but are still continuing with their investments. And I think what's interesting there is, other than the central PLI scheme, states have also done a good job to attract these investments to their states and given extra benefits to cell manufacturers to come and set up these facilities over there. Right. So it's very important to understand and try to reflect what China has done and see what we can learn from that. and what potentially where the gap lies and an opportunity for a country like India, right? So believe it or not, but most raw materials are not available in China today. And there's a conception that China has cornered the whole cell making ecosystem. Most raw materials are actually available in countries like Australia, Chile, and Africa as well. But where China has built huge strength is in processing these materials. So they import all these minerals and they convert them into battery materials, and they've built massive capacity uh, in China. And this has mainly been due to, as cell manufacturing and battery components and cell assembly grew in China, they were able to kind of ignite the industry upstream as well and develop this processing industry. Right. So between Korea and Japan also, they have scaled up. If you look at companies like LG, Samsung, SK-On, they kind of partner with raw material processors, whether it's anode or cathode or electrolyte. And as they grow, they make sure they grow with them. And that has really developed this industry. So in my opinion, the opportunity in India lies in this process materials industry, which is 92% today focused just in China. And again, if you just look at this table, on the left, all these products, all these minerals, whether it's graphite, cobalt, lithium, nickel, manganese, copper, aluminum, are coming from various parts of the world, but the anode, cathode, electrolytes, separators, and collectors are what are being manufactured in China, and really at very large scale to make them cost competitive. And when we talk about EV growth in India and the requirement of cells and battery packs in India, it's obvious that demand is growing, right? Whether it's two-wheeler, three-wheelers, buses, and even energy storage, it's obvious that demand is going to increase. And the ACC PLI has kind of jump-started the cell making, but it's very important that India have the raw materials to make those cells competitive. It will defeat the purpose if we have reduced our import bill of oil by manufacturing cells in India, but our import bill of battery raw materials remains very, very high to make these cells in India. Right? And if you're going to make 100 gigawatt hours of cells in India by FY30, that equates to about 100,000 tons of graphite, just to give you an example, and about 200,000 tons of active cathode material as well. Right? So I try to map out what is the opportunity for India here. And if you look at a 100 gigawatt hour industry by 2030, right? And what is needed to manufacture 100 gigawatt hours of cells in India? So obviously you need lithium hydroxide, nickel, cobalt, manganese. You need battery grade graphite to make anodes. You need certain raw materials to make separators, electrolyte. And we try to map out internally what are the investments needed in this space. So you need about 40,000 crores of investment just to set up facilities to cater to making raw materials for 100 gigawatt hours. So this actually doesn't include the cell making. This is just the midstream industry opportunity that lies in India. And this will generate a annual revenue of about 42,000 crores between these industry players, right? And if we don't have this battery, say the value add happening in India, yes, you have reduced due to the ACC PLI scheme, you have reduced your oil bill by 2 lakh crores. But at the same time, you have increased your annual import bill of 42,000 crores of importing raw material, right? And at the same time, you'll still be dependent on countries like China for import of raw material. So I try to calculate and put out what is the opportunity, not only for investors or say industry players, but there's a huge opportunity for the government also, which is being overlooked, which will result in tax collection and obviously forex savings from their point of view, if this industry was nurtured and developed in India. Obviously, they have to give something to industry players for them to come and invest and start being competitive. But there is something that comes back to them as well. What's also interesting to understand, it takes about 7 to 8 years to qualify. It takes about 2 to 3 years to qualify with a cell company. So a company like Epsilon, which makes graphite, We are qualifying with customers for the last 18 months. We start off with a 5 kg sample, which takes about 3-4 months to test. It moves on to a 50 kg sample, which takes another 3-4 months to test. Then you start moving into tons of samples with them. That takes about 6 months to test. Then they have their internal testing with their customers, that validation needed. So if you look at what is happening in India, and in 2025, if you have cell making in India, and if the raw material industry hasn't developed to support the cell making in India, then the raw material industry will start developing in 2025. Then it will take us 2 years to qualify. So if you look down the road, cell making might start in 2025, but the raw material industry will be qualified and be able to supply these players by 27, 28. That's too late. So it's important these investments come into 2022, 23 into India, so that in 2025, as the cell makers start, the raw material industry has also qualified and started supplying them, and they both grow in parallel, right? And just looking further upstream, what are the things that India has advantages in? India has actually a lot of natural graphite. After China, it has the maximum amount of natural graphite, but unfortunately, there aren't many active mines and not many mines get auctioned. So that is a resource maybe the government needs to work on developing. Kabel has been doing very good jobs of licensing with countries like Western Australia to secure lithium and cobalt and nickel as well. And they're encouraging Indian investors to come forward, and they're willing to facilitate these arrangements where these minerals can be sourced from Western Australia and processed in India. So again, I think that's a good opportunity that is there. But again, some help is needed for local industry players to develop, to make these investments. Okay. So in summary, I just like to say that I think the government is doing its bit, but it's more private players and industry that needs to step up and take this opportunity for a very, very high growth industry. Europe and North America have developed very strong guidelines to help industry make these investments, whether it's through capex or capex subsidies or through soft loans or even grants, which the US is giving. These really attract people to look at this in this sector, and it's obviously going to be a high growth sector in the next 10 to 15 years. Technology remains a barrier, but as a country, we understand chemical processing very well. Whether you look at Gujarat or you look at Maharashtra or you look at Karnataka, Tamil Nadu, and Andhra as well, we understand how to build industries there. There's a lot of access to renewable power in India. And these are the main things that are needed to really make your industry very, very competitive. Yeah. So in conclusion, I think there's a huge opportunity for India to develop this industry, but we need more private players to step in. Thank you.
Thank you, Mr. Handa. Thank you for the presentation. I'll just quickly move on to the Q&A section now. The first question is, India has introduced a PLI scheme to set up advanced chemistry cell battery storage manufacturing. What more is required?
Yeah, so they have set up this policy, and various companies like Rajesh Exports, Ola, Reliance want some of that. But what they expected was that, look, we are giving the cell manufacturer benefit. He should pass it down to the raw material company. But today, all these cell manufacturers are going to start off with 1 gigawatt hour, 3 gigawatt hours. They're not going to go to 20 immediately, right? So their cost structure today is not competitive. So they are not able to support raw material players to develop in India. So some kind of other policy is needed to support raw material players in India. The challenge is not as straightforward as steel or cement or power industry, because as a graphite producer, I have different requirements, maybe cheaper renewable power, access to large parcels of land, while a cathode player might want import subsidies because he's importing a lot of precursors. So it's an industry and an ecosystem that needs to be looked at very holistically, but it's a high capex industry. So definitely we need capex support to develop this industry.
Thank you. I think Dharmesh also asked the same question. Are there any incentives announced by Government of India for cell manufacturing? So,
so I can just add to that. So there are incentives for cell manufacturing, and what they've done is they've kind of put the condition on them that you have to get 25% local sourcing starting off, and it has to scale up to 60%, I think, in 3 years or 5 years, right? And what they're doing is they're slowly increasing an import duty on these products, saying that you have to develop local suppliers, otherwise you're going to you're not going to be cost competitive in 3 to 5 years when this import duty comes in. But still, it takes time to qualify, time to build this industry, time to start supplying. And it's a very niche industry where you make specific products for specific customers. So today, there's no central policy on our industry, on raw material. Unfortunately, the state EV policies also, and all the states have come out with good EV policies, don't recognize battery raw materials as a auto component. So hence, we also are not included in any state EV policy. When I say we, I mean an anode, cathode, electrolyte, foil maker, right? So we need to start getting recognized. So through certain, say, industry bodies, we are trying to develop a white paper to go to the government and Niti Aayog and say, this is holistically what the industry needs, please help us. And the other thing, obviously states are encouraging, right? So if say Ola is setting up a big factory in Tamil Nadu would be interested in giving some benefits to raw material companies to kind of partner or, be localized more. So I think with states, it's easy to discuss, but again, they have budget constraints. But a central policy needs to be framed very well. It will have to go, through a lot of steps before it comes out.
Thank you. I'll go on to the next question. He's asking, why do you think the government is acting slow in promoting graphite?
So, today, while India has the second biggest reserves of graphite is actually imported into India, right? Because it mainly goes into refractory and steel industry. And the consumption is so little that no one has really gone and developed these mines. They're mainly in Chhattisgarh, Orissa side. Today, what is really mined in India is, say, coal, iron ore, bauxite. That's because they're big industries that are say, pushed policy and brought these mines up to auction level, and they're investing in developing these mines. Today, no one is investing big into a graphite mine because the steel industry requirement is very slow. So it's met through traders importing. But the battery material industry, we see in 2 to 3 years globally, there'll be an inflection point where there'll be a shortage of graphite flake. So again, the government needs to start looking into that. You need to start auctioning bigger mines. You can't really auction a 500,000 ton mine because it will last a few years for battery material requirement. India has very good graphite for battery materials. We've tried a lot of them, and there is huge potential to develop this mining sector in India. But again, policy needs to be look at this sector and not at refractory sector. So it's again educating them a little bit.
Thank you. The next question is around startups. Some battery startups from India are signing contracts with mines to source battery raw material. What are other ways to improve the supply chain?
So, the whole segment requires a huge investment. I'll give you our example. We are going to scale up to 150,000 tons by 2030 in India, and that requires close to 9,000 crores investment. This is just in processing. This is not owning a mine or developing a mine, right? So if you go tie up with a mine, okay, that's great. You've secured raw material, but you need to build a processing facility. Our first phase in India is 10,000 tons, what we are building, right? And that can service 10 gigawatt hours. In China, the first phase is about 100 to 150,000 tons. So when you look at that scale, you start understanding that their cost structure is very, very different. So a startup going in securing raw material, that's a good move, but you have to have the ability to build a really large scale facility, because that's the only way you become globally competitive. Your cost structure at 10,000 and 100,000 is very, very different. So you have to be able to really scale up to be competitive, because that's the only thing that there's no magic wand that makes you cost competitive. It's really scale that makes you, improve your cost structure.
So the gap between the 10,000 to 100,000, that's what we have to fill to actually become a global competitor.
Yeah.
Okay, understood. So next, moving on to the next one, can we say lithium? This is what we were actually discussing previously as well. Could we say lithium ion is the best of the available batteries or not? Which of the following among nickel, cobalt, manganese is better suited?
So I think, again, there's a lot of sodium ion, aluminum, air, a lot of solid state, a lot of new technologies being developed. In my personal opinion, a lot of these technologies getting up to 90-95% at lab and pilot is very possible. Taking it that last 5% and really scaling it to a commercial technology is challenging. And a lot of Chinese companies have failed in this as well. It requires huge investment and it takes time. That said, I think all these technologies will succeed to some scale or the other, right? It's not only about having a battery that lasts 10 years, but what is the cost of that battery? That's what the consumer also looks at. So I think all technologies will be successful, and they'll have a particular application. Some might be power tools, some might be consumer products, some might be energy storage, some might be EV, two-wheeler and four-wheeler and bus might have different kind of chemistry that are more suited and more cost competitive. But it takes time, right? And the kind of investments that are going to lithium ion today, I don't think everyone one day is going to get up and be like, I'm starting to do this now because this looks better. So everything will take time and things will phase in and out as technology evolves.
Thank you. Moving on to the question by Milind. He's asking, sodium ion battery raw materials have good potential and its raw materials are in abundance in India. What is your thoughts on them? We are developing such batteries for EV and grid sectors. Are we developing?
Yeah. So sodium ion, I think, is a very good technology for energy storage, definitely. And looking at the amount of renewable power being built into India, I think it's a good application. But if you just look at sodium ion, the anode over there is something called hard carbon, right? And because sodium ion technology hasn't evolved and nobody's, say, making 10 gigawatt hours today, no one's making that much hard carbon either today, right? So as technology scales up and becomes a more, say, adopted, the raw material industry particular to that also starts adopting and starts scaling as well. But yeah, I think sodium ion has good potential. Raw materials available in India, and maybe someone like Reliance who's focused on that. If they really say, I'm going to build 20 gigawatt hours of that, that will really help even the raw material industry develop in India and support other sodium ion manufacturers in India. So yeah.
Thank you. The next question is from Kapil. He's saying, how do you think, or your viewpoint on recycling of lithium ion battery with black mass and downstream developing in India, since recycling can be a great raw material source for EVs? What else is needed from the government?
So I think the government is coming out with a really good EPR policy on lithium-ion battery recycling. What they did on lead, they're trying to adopt over here and get it into a more of an organized sector. The problem happens today, recycling is happening mainly of, say, laptop batteries and phone batteries, right? The end of life of two-wheeler and bus hasn't really come into supply for everyone. Black mass technology exists, and a lot of Indian companies have also developed it, to separate the sulfates. But then what happens? Once you separate the sulfates, you're going to sell the sulfates to China. Someone's going to make it a cathode and bring it back to India. Now, today, if a company, just as an example, if BSF came into India and said, I'm making an NMC cathode and I don't mind buying sulfates from an Indian recycler, but that Indian recycler technology has to be mature enough to give very consistent sulfates to a company like BSF, then only would you put that back into a supply chain. So what cathode and anode makers hate the most is material instability. Cost can still be adjusted, but if the material starts becoming unstable, it messes up everything. And same goes for cell companies. So it's important to do that. And on the graphite side and battery recycling, it's very, very challenging. In my opinion, not many people have done it. And as a recycler, it's very difficult to repurpose graphite to use. We have developed a technology to do that and blend it with a virgin graphite and maybe put 10 or 15% of the recycled graphite because it requires to be recoated. So again, it's not only India. I think this technology of reusing the anode and the sulfates back into cathode is still maturing, but it has good potential. But you have to little think ahead. There's no point of recovering the sulfates, selling them to China and making the cathode. You have to maybe do one more step in the process to make it more circular within India.
Sure. So I think couple also would like to connect with you post this. I will try to do that as well. I just have another question from my end. This will be more from a hydrogen perspective. Why I'm asking this is because companies like Indian Oil, Larsen and Toubro, Renew Power, they're heavily investing into green hydrogen. How do you see this as a competitive touch to lithium ion? Because Nitin Gadkari also trying to enforce green hydrogen and green hydrogen powered vehicles. How would you see the way forward for that?
So you see, it's interesting because when you look at something like green hydrogen, which is also not very mature globally, but you have really the big industry houses coming behind it, right? And putting big money behind it. So whether it's, you look at, like you said, L&T, Reliance, Adani, anyone, when such big industry players evaluate it, do technology tie-ups, my opinion is it will succeed, right? And it will mature in India and be a good supplement of power. So by the way, even in green hydrogen, there's an electrolyzer which requires a graphite carbon, which is a industry that is probably booming faster than the lithium ion anode industry. So again, in an industry like that, there are a lot of complementary products from a lithium ion supply chain to a green hydrogen as a supply chain, maybe not obviously equipment, but as a supplier. So again, it's an opportunity to look at what can we make in India with resources that we have, or maybe we have to import a couple of things to cater to these industries that are really going to boom in India. So I think green hydrogen will succeed. I don't know at what cost structure. They're very aggressive targets on that, but I think when you see big industry houses get behind it and they've done their homework, I think it will succeed.
Thank you so much, Mr. Handa. Thank you. I mean, just to close this with an ending note, thank you very much for an insightful and engaging session. It was a privilege to hear you, and our guests and I have been hooked on till the end and have taken home several nuggets. And also thank you to our leaders in the audience for joining us and for staying till the end and for always sharing excellent questions.
Thank you very much. Thank you, Gautam.
Thank you so much. Bye.